Data Science Instrument Development Manager. I think an easier way perhaps to think about it is if you think of the plane as perhaps a smartphone. One of the things I do is to manage the new apps. So what we're able to do as the technology grows, we're able to bring in new science so that we can observe and open up the universe and learn even more about it. So one of the things I think is interesting that you've heard in earlier talks is how we discover exoplanets, where we learn or where we look to find them. One of the things that Sophia can do is even answer even more fundamental questions about how do planets form, what kind of planets form where, and a really fascinating thing that I don't think a lot of people think about, but how does water move in a solar system, especially during planetary formation? How did water get here? It's one of those fascinating fundamental questions that Sophia has the technology and is developing the technology to do exactly that. So one of the things that happens is over millions of years, these disks you see that are dust and gases, they coalesce and form into planets, some rocky, some gas giants, some into just areas of separated rock. But one of the things we're really trying to learn is how does this happen? And one of the mysteries is that the bulk of gas and ice, it's hard to observe this, and it hinders us actually observing how this process works. So what we need to do is develop a new piece of technology that can see through the gas and ice and actually find out how the water is moving, how these planets are forming. So this new instrument that we're developing for the plane right now is actually going to be able to look and trace this water as it moves from ice to vapor and back to ice as it moves through a growing solar system, moving through different phases as it ages. So we can learn, one of the fascinating things is where the water will be. Whereas, as these teams you've heard before, where they find exoplanets, where they're situated in a particular solar system, do we think there will be water there? Is that somewhere we can add further exploration? I think that's one of the amazing things that we're able to do is each talk you heard is a piece of the puzzle. One of the things we work with each team, teams find the planets. We then study the planets further to find out what should be there so that we can find that next place to explore. And especially for the kids in the audience, one of the things that I want you all to know is this isn't going to be something I'm going to explore. This is something we're going to work super hard to find. We're going to develop the technology so that when you all are ready, when you all are graduating, you're going to be the ones exploring. So as you see, the water itself, we're studying how it moves. The hydrogen in these systems, they dominate the bulk of the mass. We'll be able to study all of this once we bring this new instrument onto Sophia. So how does this work? This may not work, but if it doesn't work, you're going to have to listen to me talk. It doesn't work. Okay, so what this video would have shown you is the plane itself. The telescope is fixed, but because we're a plane, one of the things that we're able to do is land after each observation. What does that do for us? It does a number of things. It gives us the opportunity to upgrade the telescope, but it also gives us the opportunity to change instruments. So at the far end of the telescope, inside the plane, what we do is we bolt on an instrument, and we go off and we look at whatever we wanted to look at with that instrument. Let's say we wanted to look at a star forming region. Well, the next day we want to go off and look at how methane moves on Mars. What we can do is get on the plane, unbolt one instrument, bolt on another instrument, and off we go studying something new. So that's one of the huge benefits of Sophia is we are able to switch out instruments and we're able to upgrade because we get to land and take off each day. So the new instrument is probably the strangest acronym I've ever had to say, but somehow if you twist it, you get Hermes into the high resolution mid-infrared spectrometer. What does that mean in English? Well, what it really means is we're studying a particular part of the infrared range of light, and we're really looking for very particular pieces of information that tell us where certain elements and certain compounds are. Hermes is going to be great at looking for water. And one of the things we really want to be able to do is take that information, use that to help all the other teams you've heard speak today to help target where we explore next, where we look for those exoplanets that could have water. So one of the things you see here are some of the goals of Hermes, but because we're looking in infrared, one of the things we have to do, and if you go by the Sophia booth, you can see this, everything emits heat. And that is definitely not something we want. So we have to get this to a temperature where the heat itself, it doesn't blind us. Hermes itself will operate at minus 459.5 degrees Fahrenheit. To put it to you in terms that I still can't get my head wrapped around that, but it is one of the coldest instruments that we have. But we have to get it that cold so that we're not blinded by the heat. The overriding theme here is how do these protoplanetary disks and systems evolve? What are we really looking at? We're really looking to learn as we move from just separated gas and dust as these things clump further and further together. How do they form? How does the water move? Where do we look next? Where are those areas of exploration that we want to focus our resources so that we find those next great discoveries? Speaking of, this picture is an artist's depiction of something that the Sophia team actually just discovered. It is a system that we're studying right now where these rocks, these gases, are clumping together. And we want to learn more about how this happens. If we can understand how these planets form and how they form with particular elements and compounds, we can understand and help the teams that are working to further explore the universe where to study next.